Question number 21. If y equals to tan inverse of 4x over 1 plus 5x square plus tan inverse of 2 plus 3x divided by 3 minus 2x, then we need to find the value of dy over dx. Now, before differentiating the given equation, we will try to simplify the given equation. So here, y equals to tan inverse. Now see, this 4x can be written as 5x minus x whole divided by 1 plus 5x square can be written as 5x into x plus, and in the second term we will divide both numerator and denominator with 3. Then it will be 2 by 3 plus 3x by 3 is x whole divided by 3 by 3 is 1 minus 2 by 3 into x. So why am I doing all these things is because there's a formula for tan inverse function. Now if I compare this portion, this term is in the form of tan inverse of x minus y whole divided by 1 plus x into y. So instead of that, I can write tan inverse x minus tan inverse y. So here it will be y equals to tan inverse of x. Now instead of x, I will write 5x minus tan inverse of y. So in place of y, I have x here. Similarly, the second term, that is tan inverse of this portion, is in the form of tan inverse of x plus y divided by 1 minus xy. So in place of that, I can write tan inverse x plus tan inverse of y. So it will be tan inverse of x, that is 2 by 3, plus tan inverse of y, that is tan inverse of x. So my equation will be simplified to this. Now here, as you can see, positive tan inverse x, negative tan inverse x gets 0. So y will be equal to tan inverse of 5x plus tan inverse of 2 by 3. So we have not started differentiating till now. We just simplified the given equation. Now we will differentiate both sides with respect to x. Then we will have dy over dx equals to ddx of tan inverse of x is 1 by 1 plus x square. So here it will be 5x whole square, and we have to differentiate 5x also, so that ddx of 5x is 5 plus ddx of tan inverse 2 by 3 is a constant, so it will be 0. So that means the value of dy over dx equals to 5 divided by 1 plus 25x square. That means the correct answer for this question is option C, that is 5 over 1 plus 25x square. Question number 22. Here, if y equals to e to the power m sine inverse of x, then we need to find the value of d2y over dx square when x equals to 0. So we will differentiate 2 times the given function. So here y equals to e to the power m sine inverse of x. So let us differentiate both sides with respect to x. Then we will have dy over dx equals to e to the power x only. But using the chain rule, we have to differentiate m sine inverse of x also. So ddx of m sine inverse x will be m is constant, and ddx of sine inverse x will be 1 by root over 1 minus x square. So dy over dx equals to m e to the power m sine inverse of x divided by root over 1 minus x square. Now we will differentiate again both sides with respect to x. Then here it will be ddx of dy over dx, and since m is a constant, so m ddx of e to the power m sine inverse of x whole divided by square root of 1 minus x square. So this implies d2y by dx2 equals to m into, here we will use the quotient rule. So using the quotient rule, we will write denominator first and we will differentiate the numerator, minus we will write numerator first and differentiate the denominator, that is 1 minus x square whole divided by denominator square. So this is the quotient rule. So it will be equal to m root over 1 minus x square into ddx of e to the power sine inverse x will be e to the power m sine inverse of x into m over root over 1 minus x square minus e to the power m sine inverse of x into ddx of root x is 1 by 2 root x, that is 1 minus x square, into ddx of 1 minus x square is minus 2x whole divided by 1 minus x square, as square and square root will get cancelled. So here you can see this 2 and 2 get cancelled, and here root over 1 minus x square, root over 1 minus x square get cancelled. So we will have m into m e to the power m sine inverse of x minus, and minus minus get plus, x into e to the power m sine inverse of x divided by root over 1 minus x square whole divided by 1 minus x square. So this is the value of d2y by dx2. Now we need to find the value of d2y by dx2 when x equals to 0. So let us put the value of x equals to 0, that is d2y by dx2 when x equals to 0 equals to m into m e to the power m. See, sine inverse of 0 is 0, so it will be 0 plus this whole portion will be 0 because there is x times, so it will be 0 divided by 1 minus 0 square. So it will be equal to m into m e to the power 0 is 1 and it will be m by 1. So hence ultimately we will get the value as m square. That means my correct option is option number C. Question number 23. Here we have dx over dy equals to u and d2x by dy squared equals to v. Then we need to find the value of d2y by dx2. Given is dx by dy equals to u. So let this be equation 1. And if dx by dy equals to u, then dy over dx will be 1 by u. So let this be equation number 2. And d2x by dy2 equals to v. Now here d2x by dy2 means d dy of dx by dy equals to v, implies d dy of, now see dx by dy means u. So here in place of dx by dy I can write u equals to v. That means du by dy equals to v, and let this be equation number 3. Now we need to find the value of d2y by dx2. So therefore d2y by dx2 equals to, so this is actually d dx of dy by dx. So this equals to d dx of, now here dy by dx can be written as 1 over u, 1 by u from equation 2. So it will be equal to, now d dx of 1 by u is minus 1 by u square, and we have to differentiate du by dx also. Okay, we do not know the value of du over dx, so for that we will use the chain rule. So I can write this as 1 over u square into, now instead of du by dx I can write du by dy into dy over dx. So this is the chain rule. Okay, now why I am doing so, because I know the value of du over dy as v from equation 3, and we know the value of dy over dx as 1 over u from equation 2. So here we will have minus 1 by u square into du by dy is v into dy by dx is 1 by u. So hence we will have minus v by u cube. So my correct option for this question is option number C, that is minus v by u cube. Question number 24. The surface area of a spherical bubble is increasing at the rate of 2 centimeters square per second. Then the rate at which the volume of the bubble is increasing at the instant when its radius is 6 centimeter. Okay, so now here we need to know the formula for sphere. Okay, the question has given the rate of change of surface area. So it's given d of A. Here A resembles the surface area of the sphere and T is our time, because looking at the given quantity, that is 2 centimeters square per second, it is given dA by dt. So it is given as 2 centimeters square per second. Now we should know the formula of surface area of the sphere. So we can write this as ddt of surface area of the sphere is 4 pi r square. R is the radius of this sphere or bubble. So it will be equals to 2. Since 4 pi is constant, so 4 pi will come in front. Then ddt of r square is 2r times dr by dt equals to 2. So here 2 and this 2 get cancelled. So the value of dr by dt equals to 1 by 4 pi r. So this dr by dt is the rate of change of radius with respect to time. But the question is asking to find the rate of change of volume with respect to time. So we need to find the value of dv by dt. So dv by dt is the rate of change of volume with respect to time. So this can be written as ddt of v. So now we know the formula for volume of the sphere is 4 by 3 pi r cube. 4 by 3 pi is constant, so 4 by 3 pi into ddt of r cube is 3r square into dr by dt. So this will be equal to 4 pi by 3 into 3r square into the value of dr by dt is 1 by 4 pi r. So we will write 1 by 4 pi r. So here this 3 and 3 get cancelled, 4 pi and 4 pi get cancelled, r and 1 r will get cancelled. That means the rate of change of volume with respect to time is simply r. But the question is asking to find the rate of change of volume with respect to r when the radius is 6 centimeter. That means we need to find the value of dv over dt when the value of r is 6 centimeter. So it will be 6 centimeter cube per second. Why centimeter cube? Because the unit of the volume is centimeter cube. Okay, that means my correct option is option number D. Question number 25. The interval in which the function fx equals to 2x square minus log of modulus of x, where x not equals to 0, is increasing. So we have to find the interval where the function is increasing. Okay, so now let us look at the function. Now in function, as you see there is log of modulus of x. Now we know that log of modulus of x will have two values, that is log of positive x when x is greater than or equal to 0, but here we will write only greater than 0 because question has given x not equals to 0. And the log of modulus of x will have negative value, that is log of minus x when x is less than 0. So when x greater than 0, we will write the function separately, and when x is less than 0, we will write the function on the other side. So here, when the value of x is greater than 0, then my function fx equals to 2x square minus log of x I will write. Okay, so now if I differentiate this function, then it will be f dash of x equals to 4x minus 1 by x. And when x is less than 0, then my function fx will be equal to 2x square minus log of minus x. And if I differentiate this function f dash x, then it will be 4x minus 1 by minus x into ddx of minus x is minus 1. So here this minus and this minus get cancelled, and f dash x will be 4x minus 1 by x. Now if you notice, the functions are different when it is greater than 0 and less than 0, but the derivative of those functions are same in both the cases. So therefore my derivative is simply 4x minus 1 by x. So this f dash x can be written as x 4x square minus 1, so it will be equal to 2x whole square minus 1 square by x. So it can be written as 2x plus 1 into 2x minus 1 by x. Now we need to find the critical points. Okay, so let me draw a number line here. So my first critical point is 0, because at denominator you can see x, and looking at 2x plus 1, I have to equate this 2x plus 1 with 0. Then from here the critical point will be minus half. So minus half will be here, somewhere over here on the number line. And another critical point I will get from 2x minus 1 is plus half. Okay, so my interval has been divided into 4 parts. Now we will check at which interval the f dash x is positive or negative. Now let us choose a point from this interval. Let us choose minus 1, because minus 1 lie in this section. So if I put minus 1 in f dash of x, then here it will be 2 of minus 1 plus 1 and 2 of minus 1 divided by minus 1. So it will be minus 2 plus 1 minus 2 minus 1 by minus 1. So it will be minus 1 into minus 3 divided by minus 1. So overall we are getting the value as minus 3. That means in this particular interval from minus infinity to minus half, the value of f dash x is negative. That means the function is decreasing here. So value of f dash x is negative here. That means here it will be positive, here it will be negative, and here it will be positive. Now as you can see, the function is increasing here and here. Okay, so the value of x at which the function is increasing is from minus half to 0 union half to infinity. Okay, so here if I see my answer, that is from minus half to 0, so x lies between minus half to 0 and more than half to infinity. That means my correct option of this question is option C. Question number 26. Here is the given function, and we have to find in which interval the function is increasing and decreasing. So let me write the function here. That is 2x cubed minus 3x square minus 36x plus 7. Let us differentiate this function. Then it will be f dash of x equals to 6x square minus 6x minus 36. Now let us factorize this function. First let us take out the 6 common, then it will be x square minus x minus 6. Splitting the middle term, we will get minus 3x plus 2x minus 6 equals to x common plus 2 common, and from here x minus 3 common. Okay, now since we have factorized the derivative, now let me draw a number line, and looking at the derivative I can see that my critical points are minus 2 and 3. Okay, so here it's minus infinity and here it's plus infinity. So 0 lies in this interval. So if I put 0 here it will be 0 minus 3 negative, 0 plus 2 positive. So positive into negative will be negative. So in this interval, the derivative is negative. That means it will be positive here and it will be positive here. Okay. The function is increasing in this interval, and after minus 2 it is decreasing, and again from 3 it is increasing. Okay, now let us look at the options. In option A, it is saying that it is increasing from minus infinity to 2 and strictly decreasing from minus 2 to infinity, which is wrong. See, this portion is wrong, strictly decreasing in minus 2 to infinity, because as we can see from minus 2 to infinity it's decreasing and also increasing. So option A is wrong. Option B, strictly decreasing from minus infinity to 3. This is also wrong. Option C, strictly decreasing from minus infinity to 2. But in minus infinity to minus 2, the function is increasing. So this is also wrong. That means my correct option for this question will be option D. That is strictly decreasing in minus 2 to 3. And yes, from minus 2 to 3, the function is strictly decreasing. Question number 27. Points on the curve xy square equals to 1 that is nearest to the origin is, let me draw a coordinate axis, and let us assume my curve is like this. So here is my origin. Now you see the nearest point to the origin to the curve is somewhere over here. So let us assume this point to be P. Now according to the question, we have to find the coordinates of this point P. Okay, because this point P is nearest point from the origin to this curve. So that means here the distance between O and P should be minimum. Okay, and that distance be, let us suppose, small letter d. And as I already said, that we need to find the value of this coordinate, that is the coordinate of P. The given function is xy square equals to 1. That means x equals to 1 by y square from the given equation. That means the value of x is equal to 1 over y square. That means let the coordinate of this point be 1 over y square comma y. Because in place of x, I can write 1 by y square, and the coordinate of y is, I am supposing, y only. And we will find the distance between these 2 points using distance formula. So by distance formula, the value of d should be equal to square root of x square. Now in place of x, I have 1 by y square whole square plus y square, and in place of y, I have y only. Okay, so this d is the distance between point O and P, and this d should be minimum. So here it will be 1 by y to the power 4 plus y square. Now let this d be written as f of y, because d is a function of y. So I am writing d as f of y equals to square root of 1 by y to the power 4 plus y square. Now my function is ready here, f of y. Now I have to minimize this, because in order to minimize this means to minimize the distance, because we are finding the point which is very close to the origin. Okay, now since my function is ready, now we know how to find the point of minima, and that would be my answer. Okay, so for that I have to differentiate this function f of y with respect to y. So here it will be f dash of y equals to, so d dy of root over y will be 1 by 2 root of y into d dy of 1 by y to the power 4 plus y square. So this will be equal to 1 by 2. Let me take LCM here. It will be y to the power 4, 1 plus y to the power 6 into d dy of 1 by y to the power 4 will be minus 4 by y to the power 5 plus d dy of y square is 2y. So it will be equal to 1 by 2 square root of 1 plus y to the power 6 by y to the power 4 into, this can be written as 2y minus 4 by y to the power 5. Now on simplifying this y to the power 4, the square root of y to the power 4 is y square, and that y square will come at numerator, then it will be y square divided by 2 root over 1 plus y to the power 6 into, let us take 2 common from here, it will be 2 y minus 2 by y to the power 5. This 2 and this 2 get cancelled. Hence my f dash of y will be y square by square root of 1 plus y to the power 6 into y minus 2 by y to the power 5. Let's take LCM here also. F dash of y equals to y square by square root of 1 plus y to the power 6 into, the LCM will be y to the power 5, and here it will be y to the power 6 minus 2. So y square, and here it will remain y cube. So that means f dash of y equals to y to the power 6 minus 2 all divided by y cube into square root of 1 plus y to the power 6. Now, since this is the derivative of my function, in order to get the point of local maxima and minima, we used to equate the derivative with equal to 0. So here we will equate f dash of y equals to 0. That means this portion will be equals to 0. So let me start from here. So we will put f dash of y equals to 0. So that means y to the power 6 minus 2 by y cube square root of 1 plus y to the power 6 will be equal to 0. On cross multiplying, we will get y to the power 6 minus 2 equals to 0, and y to the power 6 will be equal to 2. That means the value of y will be equal to 2 to the power 1 by 6. Okay. Now see, since we got the value of y as 2 to the power 1 by 6, that means my ordinate is, that means the value of y is 2 to the power 1 by 6. Now since here we know that x equals to 1 by y square, so from here x equals to 1 by, the value of y is 2 to the power 1 by 6, so it will be whole square, and this will be equal to 1 by 2 to the power 1 by 3, because these 2 1s are 2, 2 3s are 6 will be there, so it will be 2 to the power minus 1 by 3. That means the value of x is 2 to the power minus 1 by 3. That is, the value of 1 by y square is 2 to the power minus 1 by 3. And hence, this is my coordinate, at which coordinate is nearer to the origin. So, my option C is the correct answer. Question number 28. If the tangent to the curve y square equals to x cube at m square, comma m cube is also a normal to the curve capital M square, comma m cube, then the value of small m into capital M is. So first we will find slope of the tangent to this curve at m square m cube. Okay, then we will look the other part of the question. So first the curve is y square equals to x cube. Now let us differentiate both sides with respect to x, then we will get 2y into dy by dx equals to 3x square. So hence dy by dx will be equal to 3 by 2 into x square by y. Now let us replace this y in terms of x. So here, from here, y square is y cube, that means the value of y equals to x to the power 3 by 2. So hence it will be 3 by 2 into x squared divided by, in place of y I can write x to the power 3 by 2, and on simplifying I will get 3 by 2 into x squared minus 3 by 2, which will be equal to 3 by 2 into x to the power half, and hence it will be 3 by 2 root over x. So this is the value of dy over dx. So dy over dx equals to 3 by 2 root over x. So we need to find the tangent at which point is small letter m square, comma m cube. So therefore the value of dy over dx at which point m square, comma m cube will be equal to 3 by 2 square root of, now in place of x I will write m square here because the x value is m square, so square root and square get cancelled, so it will be 3m by 2. That means this 3m by 2 is the slope of my tangent at m square comma m cube point. Now we will try to find the slope of the normal to the curve, to the same curve at this point. Okay, so in order to do that, we need to again differentiate the given function, and we will get the value of dy over dx as 3 by 2 root over x. Okay, so from here let us try to find the slope of the tangent at the point capital M square comma m cube. The value of the slope to this tangent will be capital M square comma m cube, and that will be equal to 3 capital M by 2. Okay, now see, this is the slope of the tangent at m square comma m cube. Slope of the tangent at m square comma m cube is 3m by 2. Therefore, slope of the normal at m square comma m cube will be 1 by minus dy over dx, that means 3m by 2. So it will be minus 2 by 3m. Now see, this is the slope of the normal at this point, and the question is saying that normal and the tangent at small letter m square comma m cube are same. That means the value 3m by 2 and minus 2 by 3m should be equal. So according to the question, 3 small letter m by 2 equals to minus 2 by 3 capital letter m. See, let me repeat one more time. This 3 small letter m by 2 is the slope of the tangent at small letter m square comma m cube, while this is the slope of the normal at which point? At capital M square comma m cube, because the question was saying tangent at this point and the normal at this point are same. Okay, that means they are the same line. That's why the slope should be equal. Now if I cross multiply here, it will be small letter m, capital letter M will be equal to minus 2 times 2 is 4 by 3 times 3 is 9. So my product of small letter m and capital letter M is minus 4 by 9. That means option D is the correct answer here. Question number 29. If the normal at the point, this point to the parabola meets it again at the point, then okay. So first let us find the equation of normal at this point for this parabola. So the given function here is a parabola, that is y square equals to 4bx. Let us differentiate 2y dy by dx equals to 4 into b. Differentiative, the derivative of 4bx is 4b. So here 2 1s are 2, 2 2s are 4. That means dy over dx equals to 2b by y. And this will be equal to 2b. Now in place of y, from this equation, y is the square root of 4bx. So here it will be 2 root over b root over x. So in place of y I can write 2 root over b root over x. 2 and 2 get cancelled, and if I rationalize b over root b, then it will be root b by root x. So this is the value of dy over dx. But the slope of the tangent at the given point, the point is bt1 square comma 2bt1 equals to root over b divided by root over, in place of x I can write root over b t1 square. So it will be root b by root b into t1. Root b get cancelled, so it will be 1 by t1. So This 1 by t1 is the slope of the tangent at this point. That means slope of the normal at that point will be, so slope of the normal at bt1 square comma 2bt1 will be minus 1 by dy by dx. So it will be minus 1 by 1 over t1. So it will be minus t1. So this minus t1 is the slope of the normal at the given point to the parabola. Now let us write the equation of the normal. We know the equation of normal, y minus y1 equals to minus 1 by dy over dx equals to x minus x1. So equation of normal at which point? At bt1 square comma 2bt1 will be y minus, now in place of y1 I can write 2bt1 equals to the value, the slope of the normal is minus t1, and x minus the value of x1 can be written as bt1 square. So this is the equation of the normal to the parabola at the given point. Now according to the question, let us read the question. This parabola will again touch the point bt2 square comma 2bt2. This normal will again pass through this particular point, that is bt2 square comma 2bt2. So hence it will be, so in place of y I can write 2bt2 minus 2bt1 equals to minus t1. In place of x I can write bt2 square minus bt1 square. So let us take out 2b common here, so it will be t2 minus t1 equals to, from here let us take b common, bt1, so inside t2 square minus t1 square. So here b and b get cancelled, so this implies 2 t2 minus t1 equals to minus t1 into, see, a square minus b square is t2 plus 1 and t2 minus t1. See, t2 minus t1 gets cancelled, so it will be 2 equals to minus t1 t2 plus t1. So hence it will be 2 by t1 equals to minus t2 plus. So let us check the option. In option everything is written in terms of t2, so that means this can be written as 2 by t1 equals to minus t2 minus t1, and hence from here we can write t2 as minus t1 minus 2 by t1. Now let us compare our answer with the given option. Then t2 equals to minus t1 minus 2 by t1. Okay, so my option D is correct answer here. So this is the correct answer. Question number 30. Here we need to find the critical points of the given function. So for that we need to just differentiate the function. So here fx equals to 2 by 3 x cube minus 3 by 2 x square minus 2x plus 5. Differentiating, we will get 2 by 3 into 3x square minus 3 by 2 into 2x minus 2. Here 2 gets cancelled, 3 gets cancelled. That means f dash of x equals to 2x square minus 3x minus 2. Let us factorize this. So it will be minus 4x plus x minus 2. 2x common, x minus 2 plus 1 common, x minus 2. X minus 2 times 2x plus 1. Now here, if I compare this x minus 2 with 0, then my critical point will be 2. And if I compare this with 0, then my critical point will be minus 1 by 2. That means the value of x, or the critical point of x, are 2 and minus 1 by 2. So here the correct option is Yes, option B, we have positive 2 and minus 1 by 2. So this is the correct answer.